This is part 3 of my videos about this problem set about coordinate geometry and linear functions. And the very last problem on this set asks us to find the coordinates of all the points on line C that are a distance of 5 units from point P. So here's line C. And here's point P. We found that over here in question number 4. And we're asked to find like any point on this line right here, this line C, that is 5 units away from this point. Clearly it's not this point here because this point is 3 units away. You can see that right here. So it's got to be something a little bit farther away so that the distance between these points is 5 units. Let's just think about this problem in terms of the distance formula first. And so the distance formula is the difference between the x values of my 2 points squared plus the difference between my y values of my 2 points squared. And then when I take the square root of that, I get the distance. And of course, this just comes from Pythagorean's theorem. And this is the first leg of the triangle and the second leg of the triangle. And if I square those and add them together, I get the square of the third leg. So now we could figure this out. We know D is 5. And then we know that one of our points, point P, has coordinates -2, 1, which came from problem number 4 up there. And then the hint here tells us, it says, what do you know about the coordinates of every single point on line C? Well, I mentioned this when we drew this line, is that x is always equal to -5 on this line. So for the point that I'm looking for is going to have coordinates. It's going to have a -5 for x. And then I don't know what the y value is. That's what I need to figure out in order to locate the point. It's going to be some value, and I'm just going to represent it here with this y. So let me plug all this stuff into the formula. I get 5 is equal to the square root of, let's see, x2 minus x1. That's -5 minus a -2. Let me just change that to a -5 plus 2. That's a little easier. I'm going to square that. And then I'm going to do y minus 1 right here. And square that. And so this is the equation that I'm trying to solve to find at least the y coordinate of any point that is 5 units away from line C. So I'm going to begin solving this thing by squaring both sides of the equation. And again, here I am working horizontally because I don't have enough space to work vertically. So if I square both sides, I get 25. And then squaring the right-hand side is simple enough. It's just it's going to be this thing, which is -3 squared plus y minus 1 squared. Squaring the right-hand side of this just removes the square root. And so my equation is a little bit simpler here. I'm going to go up here now. -3 squared, well, that's just 9. So I got 25 equals 9 plus y minus 1 squared. And now I can subtract the 9 from both sides. I get 16 equals y minus 1 squared. And again, I'm trying to solve for y. And so this is actually pretty nice because I can take the square root of both sides of this thing. And I get plus or minus 4. Remember, I got to consider my positive and my negative square root. And square rooting this side just gives me y minus 1. Let me do this a little differently. I'm going to say it, so 4 is equal to y minus 1, or -4 is equal to y minus 1. Those are the two equations that I get from square rooting both sides of this. Now, all I got to do is add 1 to both sides. 3 is equal to y, or negative 4 plus 1. That's a negative 3. I made a mistake right here. It's add 1 to both sides. 4 plus 1. There we go. That's 5. And if I add 1 to both sides of this, I get negative 3 equals y. So according to this result, and again, just going back to the question, it says, find the coordinates of all the points on line C that are a distance of 5 units from point P. And those are the y values. Of course, I already know the x values. So if I want the coordinates, then that's going to be negative 5, comma 5, and negative 5, comma negative 3. And I'll just put that in my box right there. And let me just plot those points back up here on the graph. Negative 5, positive 1, 2, 3, 4, 5. That's right there. And negative 5, 1, 2, 3, negative 3 right there. Yeah, that's right. And 1, 2, 3. So this distance has got to be 5 units, and this distance also 5 units. And that seems about right to me, especially from what I know about right triangles. This is 3 units and 4 units, and that's 5 units. And that's, in fact, a nice Pythagorean triple. 3 squared plus 4 squared equals 5 squared. So by plotting the points up here, I can verify to some degree that I've got all of the points that are 5 units away from this point, point P, and on the line C.